Welcome to another episode of the Practical SQL Server HA show. My name is Edwin Sarmiento, and welcome if you're joining in for the very first time. These episodes and these shows focus on tips, tricks, lessons, recommendations, best practices, errors, blunders, mistakes that I've made early in my days of implementing always on available groups, and some of my customers, so you don't have to make them, okay? With the goal of maximizing your investments in building high availability solutions, but also in a practical way where you're not wasting money. I'm practical and I'm pragmatic. I want to make sure that you are getting the most out of your investments without wasting time, wasting money, wasting resources, and still meeting your high availability and disaster recovery needs. Although my area of expertise is in SQL Server high availability solutions, this goes beyond that, because what good is a highly available database system if the application can't connect to it? So I'm looking at it from a holistic point of view, looking at the entire ecosystem to make sure that every single piece of your high availability solution is integrated properly and they work. What's the point of having one if it doesn't work well? I want to talk about the topic of this week's episode is common pitfalls when implementing always-on availability groups. Imagine you're now at that stage where you're about to implement an always-on availability group solution. You've gone through the design phase. You've ironed out all of the requirements. You're clear about it. You've defined your recovery point, recovery time objectives. You have a reference architecture in place. So let's say you decided you want to deploy a 3-node failover cluster with a 3 replica availability group, all in the same data center, and high availability is the goal. 2 nodes synchronous, 1 node asynchronous or replica, and you want to use that for reporting purposes, okay? You're now at that stage where here's the implementation plan. We are about to deploy this in production, okay? I've seen a lot of these pitfalls and you want to avoid them if you can. There are so many, but they fall under these what I call 3 big buckets, common pitfalls. And here's the thing, if you fall into one of these pitfalls, there's a 100% chance that you would experience issues after issues, kind of like unexpected outages, because these were not addressed. The sooner you catch these, the more you do not fall into these pitfalls and prevent them from happening, the more everything becomes smooth sailing. So let's get on to the 3 buckets. I categorize them in 3 buckets. First one is misconfigured networks. Now you might be thinking, I'm a database administrator. I only take care of SQL Server. I'm not a network admin. What are you talking about? Or maybe you're a sysadmin taking care of the Windows Server failover cluster. You built it and you're telling yourself, wait, I'm not a network guy. I don't know what you're talking about. And here's the thing though, misconfigured networks are sources, or misconfiguration with networks is one of the main causes of unexpected outages, okay? One of the main causes of unexpected outages, misconfigured networks. How do I explain? Oh, you have a Windows Server failover cluster. You have 2 or more nodes functioning together as a single unit, okay? And every single one of those nodes talk to each other to have a vote so that they can decide, hey, we have quorum or we have majority of votes to keep the cluster up and running. How do you think those cluster nodes talk to each other? I'm pretty sure they're not using carrier pigeons. I'm pretty sure they're not using pen and paper. You know how it is in high school, where you would write a note and pass it to the person beside you so that it can get to your friend. I'm 100% sure that the failover cluster nodes are not using those kinds of communication. Okay, not even Morse code. What they're using is what is referred to as heartbeat. Heartbeat communication is the way by which nodes in a failover cluster will send a message, the other node receiving it, acknowledging, and then responding back by saying, hey, I have received or I have acknowledged receipt of the message that you sent. I kind of look at this as you and your friend going on a ball game, or what you want to watch a game. You're coming from two parts of the city. You will use your phone, send a text message to your friend and say, hey, I am on my way. I'll meet you there. Your friend then receives that message and say, hey, I'm at the corner of 1st and 23rd. I'll see you in a couple minutes. So that back and forth messages or message between you and your friend as you're heading to that ball game is kind of like how heartbeat mechanism works within failover cluster. Now, the assumption there, of course, is you can talk to each other and you can communicate with each other using your phone, sending text messages. What if, okay, what if you cannot send a text message to your friend because you don't have a signal or you run out of battery? Not having a signal means even if you try sending the message, it is not even going out, okay? And of course, because it's not going out, your friend cannot receive it, and vice versa. What if your friend does not have a signal? Even if he tries a couple of times to send a message, it's not going to go out, and you will not be able to receive it. That is one of the kind of, I don't want to say misconfigured networks, but a side effect of a misconfigured network when the cluster nodes cannot talk to each other. When heartbeat communication cannot even leave one of the nodes to make it to the other node. Okay, that could potentially be a firewall rule that your network guy decides to roll out as part of their security policy. Okay, in this case, it's port 3343. The nodes within the failover cluster are talking to each other. Okay, and in that case, if that is blocked because a firewall rule is implemented to block traffic between those port numbers, then your cluster is not going to be able to communicate with each other. The nodes will not be able to talk to each other. They will not receive those messages. It will take itself offline. Okay, because hey, I can't talk to this guy. Maybe he's sick, or maybe he's dead. I don't know. And then the cluster will decide we don't have quorum. We'll take ourselves offline. Again, side effect of misconfigured networks, and that's just one common example. There are other common examples, like for instance, I'll use that same example. You're texting your friend. You're sending messages to your friend. If you're within the same city, you probably get it within, I don't know, a second. 2 seconds, less than a minute, because you're within the same city. Now, imagine if you're in a Super Bowl game and you're trying to send text message to your friend. There will be congestion because there's so many people also doing the same thing, sending text message to your friend. So the network provider is saturated, whether you're on AT&T or T-Mobile, it's saturated. So even if there was no firewall rule blocking the cluster nodes, if the network is saturated, same thing. I kind of use the analogy of having interstates in the United States. We call them Queensway up here in Canada, and the example that I use is one of those interstates in Florida, Orlando specifically, where you have 6 lanes. You can go as fast as 80 miles an hour. Doesn't matter if you can go 80 miles an hour if there's bumper-to-bumper traffic. You're not moving. Okay? So imagine if your network is congested, just sending those heartbeat messages. Okay? You don't have firewall rules blocking the message, but the network is congested. How will the node be able to send those messages to the other nodes and vice versa? How will they be able to receive it if the network is congested? It's one of the reasons why it is highly recommended to have a dedicated network adapter for heartbeat communication traffic, although that's really not relevant in today's world because Microsoft configured failover cluster to use any available network adapter. But that's also the reason why it is recommended to have more than one network adapter, so that when one of the network adapters in your failover cluster is unavailable, the cluster will use the other path. Okay, it's just like using multiple routes to get to the other cluster nodes. But that is another example of misconfigured networks. I've seen so many cases where a cluster will have a single network adapter. Yep, the cluster validation is not going to block you from creating the failover cluster. It's just a warning. So you can go ahead and create the failover cluster with just one network adapter. Oh, by the way, that network adapter is connected to your main production network where everything is going through. Meaning it's more than just the cluster communication traffic going through that network. It's what your availability group data replication traffic uses. It is what your client application uses to connect to the database. It's what your management tool and your monitoring tool uses to connect to the database and monitor. It's what your backup utility uses. So it's saturated. Kind of like the interstate where you got bumper-to-bumper traffic, even if you got like 6 lanes. And you can drive at a maximum of 80 miles an hour, you're not moving because it's packed. Okay? Again, nothing to do with a failover cluster, nothing to do with SQL Server, but because your nodes are connected to the network and they're talking to each other using the network, any misconfiguration like bandwidth allocation and quality of service on the network side could cause outages. Okay? Could cause potential issues. One case that I worked on a couple of years ago where we deployed the always on availability group, and I noticed in the Windows event log there were series of events pointing to a file share witness that is flaky. File share witness is on a different part of the network. It's on a dedicated machine, but I see, disconnect, reconnect, and I told the sysadmins, hey, you might want to have a look at this because the file share witness is flaky. And I see dozens and now hundreds of error events telling me that there's something wrong with the file share witness. They said, sure, we'll fix it. So they have a 2-node failover cluster with a file share witness. File share is flaky. They didn't bother. One fine Tuesday, when Patch Tuesdays normally happen, they decided to install Windows patches on the secondary replica of the availability group and then rebooted it. That's a recommended best practice, isn't it? You install patches on the secondary, perform maintenance, reboot, and the primary replica will still be up and running. Their entire availability group went offline. They were trying to fix it. They couldn't bring it back online. Gave me a call and look at the issue. Managed to bring the availability group online as quickly as I possibly can. And when they asked me what happened there, they did not like my response. Okay, I explained to them, look, you have a 2-node failover cluster with a file share witness. That gives you a three votes for your quorum. To achieve majority, you need 2 votes out of 3. You took down your secondary replica, right? You rebooted your secondary replica. Oh, and by the way, your file share witness is flaky, so that's 2 down out of 3. So you're down with 1 voting member, so the cluster will decide, hey, I'm going to take itself offline. That's by design. Yeah, they did not like that response. And I told them, look, this is one of the reasons why you have to really monitor your network. Cluster heartbeat communication is happening. Cluster needs to make a decision based on the availability of voting members. Even if the primary replica is healthy, nothing's wrong with the database, nothing wrong with the cluster, nothing's wrong with SQL Server, the cluster will still take itself offline because of a network issue, because it cannot talk to the other nodes, and because it could not achieve majority of votes. I can spend so much time talking about misconfigured networks because this is a common thing. This is a very common thing. It's also one of the reasons why if you've seen or the topic that I talked about a couple of weeks ago, where I no longer recommend stretched failover clusters and availability groups where you have nodes in two different data centers and availability group replicas in two different data centers. That I no longer recommend that, because you're putting your high availability at risk because of some network issue that you have no control over. Okay? That's why I no longer recommend it. I can spend so much time talking about this because, again, we're just talking about heartbeat communication. What about session timeout from the point of view of SQL Server? What about same subnet delay and same subnet threshold parameter values, the frequency of the heartbeat communications? What about host record TTL and register, all of these things? Okay, the failover cluster relies on so many networking stuff in order for it to work. So if your network administrators are just doing their thing, they're not aware that they're actually causing issues, and they're just doing what they've been doing as part of their day-to-day jobs. So please let them know, inform them that what they could be doing could potentially cause outages on your existing availability groups. And you really do want to do this on the implementation stage, okay? Because part of that is also communicating it to your network administrator. So moving forward, they can expect, hey, I cannot do this, meaning I cannot block 5022 for availability group replication traffic. I cannot block 3343 for failover cluster node communication traffic. So anytime they would implement a firewall rule, they would have to keep that in mind and not roll out a firewall rule that blocks those ports. And again, I can spend so much time on this, even though it's not a DBA task, even though it's not typically a sysadmin task, it's most of the time a network administrator task. You have to let your network administrators know, especially in large organizations where you have segregation of duties. So that's the first one, misconfigured networks. Like I said, I could speak about this because it's one of the main reasons why always-on available groups would not just fail over, but sometimes the cluster will take itself offline, and then you have an extended, unexplained, unplanned outage. Okay. The second one is underestimating data replication volume. Okay. Underestimating data replication volume. Your always-on availability groups are also talking to each other, and the primary replica is sending transaction log records to the secondary replica. I call that the data replication, but the replication happens at the physical layer, meaning it is exactly what is written to the transaction log record onto the primary that gets replicated over to the secondary replicas. Okay? It is kind of difficult to estimate the data replication volume if you do not have a baseline. What do I mean by that? This is a brand new installation. You don't know the workload profile. You don't have any idea what it looks like. So you just kind of provision not just the storage, but also the volume. Okay? And then you implement this, you roll it out in production, you start introducing transactions, you connect the application to the database, and you start looking at the transaction log, or the data transaction log record, the volume of transaction log records generated. Normally what I do, if you have an existing system that you're just converting into an availability group, meaning you already have a standalone instance, it's working fine with client applications connecting to it, the way I estimate data replication volume is I look at the history of transaction log backups. Because always-on availability group data replication is no different from real-time sending transaction log records from the primary to the secondary. That should give you an idea, an estimate, okay, of how much volume is generated. Let's say you have a transaction log backup running every 15 minutes. You kind of have an idea. And then, grab the records from the MSDB backup history table, plot it on onto Excel or Google Sheets, and then you can somehow get an idea of the volume of transaction log records generated. Remember the first point about misconfigured network? Those transaction log records will be sent over to the secondary replica. Guess what SQL Server uses to do that? The network. This also ties back to that. So part of that is understanding, is the volume of the transaction log records generated on the primary as being sent to the secondary, is my network capable enough to handling that volume? Okay, because, and I used the example earlier where there are so many cases of Windows Server failover clusters that only have a single network adapter. Literally, single network adapter. The one of the cases that I worked on several years ago, this was not an always-on availability group, but the failover clustered instance. Big global gaming company that you are probably familiar with. Their failover cluster has a single network adapter, and I asked the engineers, why is that? Okay, what they did was they had like 4 network adapters teamed and presented to the Windows Server failover cluster as a single network adapter. So they have 4, but are teamed, so it only looks like a single network adapter. That's fine. Okay, that's fine. Which means you now have, if we have like a 10 Gbps network adapter multiplied by 4, in total they have 40 Gbps. That's fine. Okay. Hopefully those 4 network adapters are not plugged into the same network switch, because now you have a single point of failure. Going back to misconfigured networks. Okay. So you have 40 gigabit per second as a combination of 4 network adapters. The volume of your transaction log records being sent to the secondary replica should not be more than enough to saturate that. Okay. Realistically, of course, it all depends again on the amount of transaction log records as a side effect of your log backups, if it is an existing system. If not, then you have to guess. But the challenge there is, well, I have to configure my always-on availability groups to send data replication, to send the data and replicate that data across the different replicas. And by default, okay, by default, it will use the same network adapter as what I call the production network adapter. This is the network adapter that your client application uses to connect to the database. It's the same network adapter that SQL Server uses to authenticate to Active Directory. It's the same network adapter that the failover cluster uses for cluster communication traffic. It's the same network adapter that you're probably using for backups. What else? If that's a VM, it's probably the same network adapter that you're using for VM snapshots. And think about this, and again, I'll use the same analogy as I used in the previous point. 6-lane interstate, where you have a maximum of 80 miles an hour. You're not moving if you have bumper-to-bumper traffic. So, underestimating data replication volume, understand which interstate you're sending those data into, and make sure that you have enough bandwidth, going back to networking, you have enough bandwidth, and also calculating other causes of transaction log record volume. Okay. Again, most of the time we're looking at transactions based on the application sending data to the database. But what about index rebuilds or index maintenance, whatever kind of index maintenance, where you're using all the Hallengren scripts for smart index maintenance, but running index maintenance, whether that's rebuild or reorganize, is generating massive amount of transaction log records. How are you pushing that? Or how much transaction log records are generated in addition to client application transaction log volume is replicated alongside with that? And do you have enough bandwidth? I've seen cases where in a very busy system, customers would pause their index maintenance jobs because the secondary replica could not catch up. It's a side effect of multiple things. Networking is one of them, but also the secondary is underpowered, like an underpowered either machine, physical machine, or virtual machine. But the thing is, you have to take into account all of the potential transaction log records generated from transactions external, and I say external meaning it's coming from inserts, updates, deletes, any type of DML and DDL statements, plus internal transactions, SQL Server generated transactions like page splits, index rebuilds, or any internal processes that SQL Server does and causes a transaction log record generation. So keep in mind the data replication volume. I had a client work on this a couple of years ago. They are kind of like an emergency response system, similar to 911. They have their application sitting on an availability group, and they cannot afford millisecond or 3-second delay even. Okay, because if you're an emergency response system, delays could spell the difference between life and death. And so they could not afford 3 or 5 second delay in the transaction latency. And so they started performing index maintenance on certain sections of their tables, not realizing that it is causing more delay because they configured their availability groups with synchronous replication. Part of the stopgap, the mitigation strategy, was to switch the replica to asynchronous while they're doing this. After the index maintenance, switch it back to synchronous. They understood that there's a risk of potential data loss, but the potential data loss is better than somebody who's calling for an emergency and not getting processed properly. So again, you have to understand the activity. Okay, the transaction log records generated as far as client applications connecting to the databases, as well as internal SQL Server transactions that generate transaction log records, like, again, page splits or index maintenance. Again, it's easier if you have an existing system where you can look at the backup history, particularly the transaction log backup history, where you can estimate the size. But if it's a new implementation, well, you kind of have to constantly monitor and then do a linear regression on how much transaction log records are going to be generated within the next 5 or 10 months if it's a new implementation. Okay, I can again dive deeper into this and what are different causes, maybe in another episode. The third one rather is insufficient testing, and I'm not just talking about failover testing. I kind of put everything in this bucket because you have to test what I call the RAP framework. You have to test for reliability. Okay, reliability in the case of what happens when one of my replicas die. For whatever reason, okay? Does your failover cluster function the way you want it to function? Availability. What happens again if, let's say, I lose quorum and or I lose a file share witness, but I still have majority of votes? How will my failover cluster behave? Okay, and performance as well. And we're not just talking about availability group performance, where you have to constantly monitor for availability, but also stuff like I'm generating massive amounts of transaction log records, I'm rebuilding indexes, but then my transactions are getting slow because I need to wait for those transactions to be committed on the secondary before they'll be considered as committed transactions. So a combination of all of these, when it comes to failover clustering tests, reboot the secondary, unplug the power cable, unplug the network cable, restart SQL Server on the secondary, that is, kill the processes, see how it behaves, so that you're not surprised and you're not get thrown off with unexpected results. One of the examples that I use here is a couple of years ago when one of my clients decided they want to build a failover cluster. They got an enterprise grade storage subsystem for their nodes, This is not for availability groups, but applies to availability groups, where they have, if I'm not mistaken, they have iSCSI for their storage subsystem. And the storage vendor promised them, look, we got like network teaming, we got 4 network adapters, so you are getting, again, doing the math, 10 Gbps times 4, 40 Gbps. So we were testing how the storage would behave as we are unplugging network cables. We unplugged one of the network cables. We kind of expected a blip, and then from 40 it would go down to 30 Gbps. In this particular case, what happened was we unplugged one of the network cables, and then all of a sudden it dropped down to 10 instead of 30. Okay, we reached out to the storage vendor. They realized, oh, we did not give you the firmware in that would make that possible. Okay, so rigorous testing. You want to make sure that you're getting what you paid for. Okay, that is also applicable for data replication traffic when you're configuring always on available group. If your hardware vendor promised, hey, this is NIC teamed, you got the firmware, you test it. If you're generating, let's say 100 megabytes worth of transaction log records, and then you're pushing it across the replica, test unplugging one of the network adapters, see what happens. Is it just drop down to less than the capacity, or did it blip and all of a sudden you can no longer communicate? Okay, you want to make sure that you are getting what you paid for. So that's part of reliability. That's also part of performance. Okay, you want to make sure that your client applications are able to do what they need to do despite you performing all of these tests. Okay, again, your goal is high availability, so your application should never even realize that something went wrong. Okay, automatic failover. Did the client application successfully reconnect after a failover happened? Oh, and by the way, did the failover actually happen? Because I've seen cases where somebody would assume that a failover would happen, because why not? Failover clusters are there for automatic failover, isn't it? Well, if you don't test and if you don't understand the minimum requirements, meaning conditions, there are at the minimum 5 conditions. All conditions need to be met in order for automatic failover without data loss to happen. So that is part of your testing. Okay, making sure that you're taking all of these into account. And like I said, I've compiled them into 3 major buckets: networking, network configuration, data volume, okay, the amount of transaction log records generated, and insufficient testing. There are other things within those buckets that could impact availability of your databases in an availability group if you don't properly do them. Again, networking, data volume, data replication volume, and insufficient testing. Prepare, rigorously test, make some estimates, ask questions, do some testing in order for you to properly provision the right hardware, the right resources, and tweak those configuration settings accordingly in order for you to prevent issues like outages from happening. Okay, and again, we're trying as much as possible to make the implementation as, I don't want to say problem free, because again, there will be problems. It's just a matter of preventing them from happening in the first place. That's why what I do is I would do all of these things iteratively before I even cut over to production. Test, implement, test, tweak, measure until I'm happy with it, and then I'll document. And then I'll rebuild everything based on the new configuration settings, and then once I'm happy, cut it over to production. Okay? You will not know until you test, until you measure, until you improve. And that is what this episode is all about. That's about it for this episode, and tune in for another episode of the Practical SQL Server HA show. And if you need help, let's say, again, you already have the the plan, you've already decided on the reference architecture, you want to build it, but you're not quite sure of the nitty-gritty details of the network configuration, the transaction log volume, the data replication that you need to, that's being generated, or to do more rigorous testing, feel free to reach out. That is the URL to my calendar page. Visit the site. This will redirect you to my online calendar where you can pick and choose a time that works for you. I call them strategy sessions because in that call, we are going to focus on two things. One, understand where you're at. Are you in the design phase or are you ready for implementation? Two, what are your challenges? Okay, understand what your challenges, and maybe three. Third one is come up with a strategy session or strategy of whatever approach you need to do in order to get to where you want to be. So let's say you already have the design, you just want implementation. That's the goal. Get it implemented and cut over to production. Or maybe your team is not ready to support it after cutting over to production. Again, whatever situation you may be in, use that link on the screen, schedule a strategy session. Let's have that conversation. More than happy to help you in any way I can. That is about it for this week's episode of the Practical SQL Server HA show. Enjoy the rest of your week, and I'll see you again next time.